Welcome protein coders. Let's build some coding muscles. Today we're going to solve a problem, maximum non-negative product in a matrix. It is available on Leetcode as problem number 1594. So what problem says is, in our given grid, we have to move from start to end. And we can only move left, right side or downwards. And let's say if all the values are positive in our grid, then simply as in the previous questions, what we will do is we will move left and we will move right if we are moving from the bottom to the top corner, end to start, and we will take the maximum of the products. But the twist is here we have negative values also present in our grid. Okay, and because of that we have to consider a few changes in our approach. So let's discuss few cases. Suppose I get two values from left side and from up side. Okay, if I am moving from bottom right to top left. So suppose these values are 1 2 minus 1 minus 2 minus 1 2 and 2 minus 1, and the grid value is 1. Then I will have these two choices, right? And if I take the maximum, 2 minus 1 2 2 will be the answer. And in second case, if the grid value is negative, then here minus 1 will be the maximum product, here 2 will be the maximum product, here 1, and here also 1. So if you observe, in the first case, the maximum of left and up, or the maximum of both from both the ways, is giving the answer after the product from the grid value. But in the second case, the minimum of the both paths after multiplying giving us the answer. So we need to store the maximum and the minimum value also. So we will store minimum and maximum for each ij, because we can obtain answer from any two of them. Okay, so let's first declare our function. It will take ij and the grid. Okay, and let's declare maxi and mini. Maxi with long min, mini with long max, and let's get left max and left min using our DFS or recursive call. Okay, then maxi will be the maximum of the maxi and the grid value multiplied by both the left max and the left min, similarly the minimum. And remember, it should only done with when j is greater than 0 for avoiding out of bound issues. Okay, and similarly from the upward side also we will do the same. Okay, we will see this in the code. Now for the base case, if its I and j becomes 0 0, we will simply return the grid value for both minimum and maximum. Okay, so what we're doing is, for every grid ij we have 4 components, right? We are taking maximum of all of them and minimum of all of them. Let's see in the code. Let's get the maximum product from our solve function, and we will return minus 1 if our maximum product is less than 0. Okay, it's given in the question. So let's write our base case, define maxi mini, and if j is greater than 0, we will get the left max and left min, right? And we will update maxi mini again. For I greater than 0, we will get the up max and up min, and we will again update maxi mini. At the end, we will return maxi and mini. Let's see. And yes, example test cases are passed. Let's submit. And yeah, we got time limit exceeded. Congratulations. Let's memorize our code. So if you see, our I value is going from n minus 1 to 0 and j is going from n minus 1 to 0. So obviously we will have a 2D dp vector, and it will store a pair of long, one for maxi and one for mini. So we need a 2D vector dp, okay, of pair of long. Let's initialize it, and the values will be long min and long max. Long min because first value is the maxi. Let's pass this dp everywhere in our recursive calls also. At the end, we will store the value maxi mini in our dpij, and we will also insert the check, and that's it. Let's quickly submit this. Yes, example test case is passed. Let's submit. And yes, we have passed all the test cases. Now let's see the tabulation part. So in memoization, we are moving from m-1, n-1 to 0, 0. So in tabulation, we'll move from 0 to n-1, 0 to m-1. And from the base case, we know the value of dp of 0, 0 will be simply grid 0, 0, grid 0, 0. Okay, and our answer will be finally at dp of n-1, m-1. So we will have two for loops, one for I, one for j. Let's initialize dp00 with grid 00, comma grid 00. Now if I is 0 and j is 0, we will continue, or else we will have defined two values, mini and maxi, and I will just copy the recurrence relation, and instead of the function call, I will write dp. And finally, I will store dpij equals to maxi mini. And at the end, what we need to do? At dp of n-1, m-1, we will have both maximum and minimum. So we will take the maxi and we will check. If it is negative, we will return -1, or else we will return result. So let's code this up. Let's first define the modulo in type defs. Let's create a dp vector, 2D vector. And let's initialize dp00 with grid 00, grid 00. Now we will have two for loops. If I and j both are 0, we'll continue, or else we will have maxi and mini, and exact recurrence relation. If j is greater than 0, we will get left max and left min from the dp ij -1. Remember this, and rest is same. Similarly, if I is greater than 0, we will do the exact same as in mentioned in recurrence relation. Finally, we will get the rest and check. Let's quickly summarize. Okay, wrong answer. Why? Let's see. Okay, we forgot to do the modulo finally. Let's now submit this. And yes, congratulations, we have passed all the test cases. Now let's see the space optimized way. So if you observe in our recurrence relation, we are getting left max and left min from the dp of I, comma j -1, and up max up min from dp of I -1, comma j. That means for any value in the grid, I am getting the values from just the upward cell and the leftward cell. Okay, so I am only dependent on the upward cell and leftward cell, and it is very similar condition as we have seen in our previous problems also. We will take just two vectors, okay, previous and current. So let's define them, and the rest will be the same. We will have two for loops. If I and j equals to 0, current j will be value, comma value, or else we will define maxi mini, and for getting left max and left min, we will get from current j -1. Okay, in the current row vector, left side value, and for the up max up min, we will get it from previous j, right, directly upward cell. Finally, current j will be maxim, comma mini, and we will assign current to previous. Let's quickly submit this. Okay, we have a typo somewhere. Oh yes, when I and j are 0, should be grid ij, not 0, 0. Let's submit. And yes, we have passed all the test cases. So that's our space optimized solution. Okay, now let's see the time complexities. For recursive approach, for every cell we have two options, so it will be of order of 2 to the power n, which is exponential. For memoization, you are filling a dp vector, right? So it will be order of m cross n. And space complexity will be of order of m cross n multiplied by 2, because we are storing two values. You can ignore 2 also. In tabulation, it's similar to the memoization, but in space optimized solution, we are only having two vectors, previous and current, of size 0 to m. So time complexity will remain same, but the space complexity will become 2 times m. Okay, so that's all from my side. I hope you learned something new today. If you have any questions or queries, please mention them into the comment box. You will find the problem and the solution link into the description box. Let's meet in some new video. Till then, keep practicing, keep smiling. Thank you.